Okay. So the buffer system, as I mentioned on the video by Dr. Dave or Professor Dave, is actually a, a chemical or a solution that is able to resist chemical changes or pH changes when you have small amount of acid is being added. Okay. Now, and at the same time, it's also acting as a neutralizing agent when you add either rich acid or base into the solution. Okay, and then it contains either significant amounts of weak acid and its conjugate base or significant amounts of weak base and its conjugate acid. Teka lang, wait lang. Ano ba yan? Wait lang. Okay. And then at the same time, an example of a buffer is the one that we have in our blood, which is carbonic acid and then bicarbonate. So yung weak acid natin is the carbonic acid here. Let me just show this one. Yan. So ito yung weak acid natin. And then this is our conjugate base. Okay? So yan. So in making a buffer solution, it contains, as I mentioned, containing weak acid and weak bases. Now, the one that you're looking at right now, usually this is the one that we have for the basic example for, or the most common example for buffer solution, the acetic acid buffer. Kaya nga, if you're going to look up in most books or online resources, lagi nilang sinusulat acetic acid. Okay? As their reference compound or their reference acid. Okay? And then, kaya nga yung iba naman, pag sinulat natin dyan, wait lang, wait lang guys, ano ba yan? Saan na ba yun? Nawawala. Okay. So, wait. Naglo-load lang. Inad lang ako na ano eh, ang annotate ko. So, most of the time, you will see it as HAC. Yan. Yan. That's the sign that you're going to see on most chemical equations that would give you association. Remember, this is a weak acids, and weak acids tends to partially ionize or partially dissociates. So, ibig sabihin, it will have each component may be present all the time. Okay, so it will dissociate into hydrogen ion concentration plus acetic acid salt. Okay, and now, okay, now what would be the action if for a buffer solution is that when you add now a strong acid, it's going to be neutralized by the weak acid. For example, if you have a base like sodium hydroxide, and the equation would show like this. So you have sodium hydroxide aqueous plus acetic acid aqueous will give you water and sodium acetate, sodium acetate, yeah. Okay. And if the amount of sodium added is added less than the amount of the acetic acid, then the pH change will be very, very small. Okay. Now, if you're going to be having a strong acid, again, the one that will be acting on the strong acid when it is added on on a buffer solution would be the conjugate base. Okay. So that would mean here in the equation you have their hydrochloric acid plus sodium acetate. So, yan yung magre-react. Okay? And they will be forming acetic acid and sodium chloride. Now, hindi na napuntin po yan i-consider sa equation. They'll take note that sodium chloride is a salt and salts are not involved in buffer solutions. Okay? We also use the term spectator na lang sila. Okay. Now, if the amount of hydrochloric acid is less than the amount of sodium acetate, the pH change it will definitely very very small. Okay. Now, this is what it's gonna be looking like in terms of managing an acid buffer solution. Now, this is based on Le Chatelier's principle for weak acid equilibrium. Okay. And then, so as I mentioned, those components that are inside it would tend to react. Now, take note that the hydrogen ion concentration or the hydronium ion concentration and the hydroxide concentration or the components of hydroxide will be um, producing water, and then it's going to be shifting the equilibrium. Now, if you're going to recall your chemistry for Le Chatelier, ito yung nagmo-move siya. I'm not going to go into that one, but at least the principle states that it will have an effect on the movement of the solution. Is it going to be a forward reaction or a backward reaction? So, for example, given the case that you have here, you have an acetic acid. So, si pointer. Yan. So you have acetic acid here, water, um, or acid ion, or yung acetate ion natin, and then hydronium ion. So if in case we're gonna add, let's say, more acid onto the equation, pag nag-add ka ng more acid, it will produce more hydronium ion in the process. Kakainin niya yung hydroxide, ay yung water. So it will increase the hydronium ion concentration and also increase this one. Okay? And if in case nag-add ka naman ng base, it will force backward reaction. So, as I mentioned, it's not going to be directly going through the details of the whole Le Chatelier's principle, but more on how it's going to be affecting it. So, here is a diagram how the reaction would happen. Okay, ito yung actually nakita ko na medyo maganda-ganda yung pagkakapresent niya, eh. So you have here your acid, okay? So you have your acid and you're going to add a strong base. So you had the OH is always a representation of a strong base, okay? Yung HA is the acid. Okay, so when you add now this one, it will react to, hala na wala siya. Okay, it's supposed to react with the HA. Wala siya ka. Kalimutan ko, I'm using um, Google Slides, eh, kasi hindi lahat ng PowerPoint nakikita doon. Wait. O yung mismong animation. Okay, wait lang. Yan. So, can you see my screen again? Hindi. Wait lang. Baguhin ko yung ano. Hindi pala nakikita din. Kasi, it's using tabs. Okay. So, advice nyo na lang. Nakikita na? Screen ko. Nag-e-echo siya tuloy. Yan. Can you see my screen now?
Yes po.
Yes
Okay.
po.
So here, let me start again para makita niyo yung buong animation. Medyo limited pa nga as I mentioned, may limited pa ang Google Slides. So here you have there the base that's going to be added into solution. So this is already in equilibrium. Okay? So in equilibrium, you have your acetate or your conjugate base, and then your hydronium ion concentration. So pagka-add natin siya, it will interact or will react with the acetic acid. Okay, and once it reacts with the acetic acid, it will be consuming the acetic acid for the neutralization. And once it does happen, it will actually reduce the concentration of the acetic acid. And then it will, di ba, magpuproduce siya ngayon ng bagong conjugate bases, and it will add now to the concentration of your conjugate base, thereby increasing the amount of your uh, conjugate base concentration. So, ulitin natin ha. So, here again, so you have a strong base added. It will consume your acid concentration, your acid, thereby decreasing the concentration. And once it's already decreased, you have your new acetate ion or conjugate bases produce, which will increase the concentration of your conjugate base. Okay? So yan po yung concept ng reaction sa buffer when you have a strong base is added. Okay? Now, question so far guys before I proceed.
Wala naman po.
Okay. So this time it's going to be talking about, thank you by the way, Asaya. We're going to be talking about how about a strong acid. So usually, as mentioned earlier, if you have a strong acid that will be reacting to your acid, it's not going to be uh interacting with the acid here, okay? But it will be interacting with the conjugate base, okay? So it will reduce the amount of the conjugate base and producing more acid in the process, okay? So if you're going to look at the animation, again, we have our equilibrium here. So if you add a strong acid, so again, represented by hydronium ion here, it will interact with the conjugate base, reducing the concentration of the conjugate base. And then the new acid formed will actually be adding to the concentration of the uh, weak acid. Okay, so if you're going to dramatize here on a picture, this is how it usually looks like. So if you have here yung sinasabi ko sa inyo example ng acetic acid, when you add now acid, it shifts to the left, increasing the acid, reducing the conjugate base or the acetate ion. And if you have a hydroxide, it increases the acetate ion, reducing the uh, acetic acid. So ito lang tatandaan ninyo when it comes to talking about the buffer reaction. Okay? So now when you add now yung mga salts in the solution, it will just be adding to the movement of the equilibrium towards the left. So ito lang. So pag nag-add ka ng more salts, you're gonna be producing on the left side. Okay? Now, this causes the pH to be higher than the pH of the acid solution and lowering the hydronium ion concentration. Okay? So this is an example of what it looks like. So you have here, if you're going to do a laboratory experiment, you have a pH meter. Okay, so you have there the electrode is dip ngayon siya. So you have here a zero point 0.1 molarity of acetic acid, and that is a pH reading of 2.9. Now you have there sodium bicarbonate of zero point 0.1 molarity. Okay, that's 8.9 pH as shown here. And when we added them together, both zero point 0.1 and zero point 0.1 of the same of the two chemicals, you will see that there is a shift on the pH level. So they meet halfway. Okay? So yeah. Now, another way of explaining this is using the Henderson-Hasselbalch expression. So in the Henderson-Hasselbalch expression, remember in last session we used the Ka expression. This time we're going to be using the power of Ka and the value of the log of the base of the acid. Um, in some ways, this is much easier in terms of calculating the pH given that you have pKa. Now, but take note, you really have to make sure that you change the expression from Ka to pKa, lalo na kung ang given sa problems niyo is more on the Ka value. Okay, so always remember that Ka, ganun din ang gagawin nyo, just do a negative log of pKa. Okay, wait lang guys. Saan na yung aking ngayon? Okay, so paano po itsura yan? You have there, so pKa's, yan. So you have there pKa. Pasensya na sa handwriting kasi medyo malapit sa pangit yung pagkakalagay ng ballpen ko. So you have their pK is equal to the negative log of Ka. So yan. So yan lang po yung gagamitin natin na formula when we compute for the pKa. So sabi ko nga sa inyo, this is the easiest to remember. Okay, so we'll have now um, examples on calculation. Let me just end my presentation. Okay. Now, I'm not sure if you could access this if you're looking at my screen right now. Okay. So this is what we call a jam. Now, I'm not sure if para ito na lang titignan ninyo. Wait lang. Let me control my sharing. Okay, wait. Can you access the jam on your end, guys? Or hindi? May kita nyo kaya?
Na-o-open naman.
Na-open naman sa inyo. Pero at least nakikita nyo siya ngayon. Wait lang ha. Okay, so this is what's gonna be look like. Wait lang. Ano ba yun? Okay, so let's have an example problem on a buffer system. Long screen. Wait. Ouch. Yan. Okay, so you have here now a problem. So you have formic acid that is prepared with zero point 0.1 each of formic acid and then and sodium formate. Now the ionization constant of acid formic or formic acid or Ka is 1.8 times 10 to the negative 4. Okay? Now it's asking for the pH of the solution. Wait lang guys ha, meron lang akong pasaway. Okay. So let me go back. Yan. Okay. So first thing you're gonna do is of course write first what are your givens. Okay. So ang given mo is concentration ng talaga nasulat ko pag ganito sa screen. Wait lang guys, magmo-modify lang ako konti. Wait lang.